Solve the equation over the interval 0, 2 pi, where 0 is closed. Cosine of x equals sine of x minus 1. Now this is a little bit more difficult because you have two trig functions and nothing is squared, so you can't apply a Pythagorean identity and substitute right away. But what you can do is you can actually square both sides to create that situation. So I'll show you how that works. Cosine squared of x equals sine of x minus 1 squared. So we square both sides, and then I'll simplify the right side and we'll try and solve and see what it looks like. Okay, so cosine squared x equals sine squared x minus 2 sine of x plus 1. I just applied the special pattern here. Okay, now I see an opportunity here for a special pattern. Let me go ahead and show you what's going to happen. I'm going to subtract 1 from both sides. So it's going to be cosine squared of x minus 1 equals sine squared x minus 2 sine of x. We know that sine squared x plus cosine squared x equals 1. So if I want to, I can rearrange this a little bit, and I can subtract 1 here. So sine squared x plus cosine squared x minus 1 equals 0. And then I can subtract sine squared x from both sides. So that means cosine squared x minus 1 equals negative sine squared x. So now I can substitute. Negative sine squared x equals sine squared x minus 2 sine of x. Then I'm going to add sine squared x to both sides. So we're going to get 0 here, 2 sine squared of x here, minus 2 sine of x. Okay, now we'll factor. Take out a 2 sine of x from both sides. Leaves a sine of x minus 1. And remember, you can always use u substitution here if you have a hard time factoring like I did. You could let u equal sine of x and then factor first and then substitute back. So let's apply a zero product property. We have 2 sine of x equals 0 and sine of x minus 1 equals 0. So that means sine x equals 0, or add 1, sine of x equals 1. Okay, now sine of x can equal 0 at 0 and pi. Sine of x equals 1 at pi over 2. So those are our three possible solutions. X equals 0, pi over 2, or pi. Now we need to check the solutions because sometimes when you square an equation you add solutions that aren't really valid. So we're going to check 0, pi over 2, and pi. First we'll check 0. So we want to know is cosine of 0 equal to sine of 0 minus 1. Cosine of 0 is 1. Sine of 0 is 0, then minus 1. Well, 1 is not equal to negative 1, so that means 0 is out. Now let's try pi over 2. Cosine pi over 2, is that equal to sine of pi over 2 minus 1? So cosine of pi over 2 is 0. Sine of pi over 2 is 1, and then minus 1. So we have 0 equals 0. Means pi over 2 works. Let's test pi. Cosine of pi, is that equal to sine of pi minus 1? Well, cosine of pi, that's negative 1. Sine of pi is 0. Then minus 1. So we have negative 1 equals negative 1. Okay, so that means x equals pi over 2 and pi both work. Okay, so there's a lot of work here. Let me review this whole process. Started off recognizing that we had two trig functions, but nothing was squared, so we couldn't do a Pythagorean identity to eliminate a function. So squared both sides, and then applied a Pythagorean identity, the sine squared plus cosine squared equals 1. I rewrote it to make it so we could substitute into the equation here. Then, after the substitution, it's just simple algebra from there. Go ahead and make the equation equal to 0, factor, apply the zero product property, get your solutions, and then because we squared both sides, and sometimes that can add solutions that aren't really valid, we had to test them all. In this case, 0 was not valid, and the correct solutions were x equal pi over 2 and pi.